So several years back, we gave a survey, and the survey was really outlined to discuss, the majority of labs how many instruments are being used, and really, at that point, what are you using to process, interpret, and manage? And what we found for a majority of the people that took the survey was that they were using the vendor software. At that point, if they weren't using the vendor software, they were using Microsoft, such as Excel or Word, and then maybe placing that into SharePoint. But at the same time, too, they may have something in-house. And that becomes a major issue if you're not just dealing with one vendor, or if you have several vendors that are differing packages, differing instruments as well. How do you handle this? So what we do offer is we have a Spectres Processor, and it's a agnostic platform that allows you to open up any analytical data sets from any of the instruments. So in this schematic, you're just getting an idea that if you have something from Agilent, we can import the data set. If you have something from Empower, you can import the process data set and see it all in one interface to make those types of decisions just through processing. Within a project, you may have multiple teams doing multiple things at different streamlines of the project. So in the left-hand side, you have the team's project where maybe they're looking at specific stages, specific steps. Maybe for project team 2, you're looking at the targeted degradants, possible impurities, genotoxic impurities, specified impurities. But again, like I mentioned, how is this being handled right now? And the big consensus is if even in the same team, in the same projects, people and multiple stakeholders are doing this maybe very differently. Some people may be going through and putting it as a PDF in their ELN. Maybe, again, it's placed into Excel, which is a static page inside of SharePoint, internal databases, or emails. So really, that's what we're really going to cover today and just go through and see if we can streamline these results. So from there, once we've outlined the problem and test cases that we observe just talking to pharmaceutical development, we had certain challenges for ourselves as well. And the challenges came up as data visualization. If you've already drawn something in ChemDraw, Biovia Draw, our drawing package, ChemSketch, you don't want to reinvent the wheel and draw it again. So the capability of allowing a user just to take whatever they've done before and placing it into an environment where they can just upload it. Same goes for data abstraction. For data abstraction, again, my example is maybe one user has Agilent data when they're elucidating their possible degradants or building a stability indicating method. At the same time, too, they may have already processed everything through Empower or Chameleon, and they just want to upload it and just store everything together in one place. And this becomes quite useful when you start looking at data preparation. Because from data preparation, and that's where we're seeing the extent of using Excel, is you start looking at upper control limits, going through the control charts to see if any degradations or impurities are viewed at a higher level at specific projects, processes, or campaigns. So those were challenges that we saw. So in this case, going back to several slides back of what we've seen in industry, this is what we've intended for Luminata when it was very early on in adoption of how the software can help and go through specific use cases and test cases for impurity management and using those cases for Excel. But in the last version, what we've really done is open up the full umbrella of all drug development. So in this case, what we're really focusing on today is the drug substance and drug product stability and that type of workflow. We have offered, like I mentioned earlier, other cases. In this case, the question becomes, well, why is this important? And this was actually a slide taken from last week. So just imagine if we're going through this and we're using this one test case with Zantac. So why do we need everything in one place? Why do we need to know this information? If you don't, there could be repercussions. And for this case, the repercussions come to the fact that a degradant product appeared where for Zantac that could have major issues and they had to do a full recall. And from the point of view that we stand is, could have this been prevented? Was there miscommunication? Was there something not noted in a specific degradant timestamp in a stage where this was lost? And that's where the crucial thing comes in at this point is, how can you prevent this issue from arising where now when you bring it into the general public, there's a fear of using a specific product or something that's been outlined there. So this is why we thought this use case would be quite powerful and build upon for drug development. And again, these questions arise because we've seen that there's a disconnection. And within this disconnection is people that are, or users that are looking at theoretical degradants may not have access to the observed degradants or place that on one location, which makes it easier for everyone to streamline. Here is just a slide of the software. Like I mentioned before, the synthetic root process map can be anything in intention. So it can go from a process map, a batch genealogy map, or in this case, a degradant map. So here, you'll note that you have a theoretical degradant stage with all the possible predictive degradants that were observed for this one API. At the same time, too, since we can import all of the analytical data, we can take the analytical data with the molecules attached and place that as observed degradant stage. So viewing that in the same location at the same time, which becomes, again, quite powerful when you're going down the line to see what's real and what's not, to save those times and get those values out as soon as possible in one location. Another thing that's possible within the software is taking a theoretical degradant list, again, something that maybe you've done from your own experience or something that you've predicted from a third-party software. And what we allow is to take an SD file, and within that SD file, then match it with LCMS data to do some batch processing. And what the software will do in this case, it will create a live degradant map of differing time points, reference data for every degradant target that it found, and a trend plot of what's observed at differing time points to view what's occurring. And again, this is very powerful when you're in that early stage of looking at your degradants and you're just confirming and elucidating those compounds. From there as well, too, we have full capability of just looking at, let's say, an LC dataset or LCUV dataset and creating that degradant map on the fly for things that have process data here and the same things that building a trend, getting an idea of what's occurring and what we're seeing so we don't run into those patches of issues down the line when we're not sure. And again, when you have any issues, what you need today, you needed yesterday, and it becomes very difficult just to search through and look through. So from here, I'm just going to do a quick demonstration of the software, give you an idea of how it looks, how it feels, and then we'll go back to some of the slides as well. Within the demonstration portion of the webinar, I'm going to just show you how to create a degradant stage, either theoretical, where you just take in a SD file, at the same time managing observed degradants, so taking in a process data set that you've, again, from my test case, obtained from Empower, placing that within the same record, seeing everything there, and then finally viewing the batch processing capability within Luminata for stress testing. So compiling information that you have for all of your predicted degradants all in one location. So here we're just going to go through that and then go back to the slides. So this is just the interface of Luminata. If you're not familiar with it, like I mentioned, in the left-hand side is just your project navigator where you can have your project, process, campaign, your force degradation information, differing screen forms. So you're going to see that right now I'm using a screen form where it's hiding the data, but I'll show that when it gets to that point. And then also I'll show another screen form of force degradation where you can see all of the degradants and the trend plots that were built upon taking your targeted list and doing some batch processing. And then finally down below, just all the automated tools here. So in this case right now, we have our, let's say, API of interest. I can then click Import Theoretical Degradants. And when I click Import Theoretical Degradants, it's just going to find an SD file. So this SD file is just something that we had, and again, this could be from yourself, your own experience, or this could just come from any third-party software. And then from here, you can just import that. So in this case, I select it and I open it. When I do that, I can choose the metadata fields that I'd like to appear while linking to that stage, and when it does that, it will just show up within the tables associated with it on the right-hand side. So in this case, you'll note right away that you have created a new stage right here. And if I zoom in, if you can see it better, just those are your theoretical degradants that were viewed, and it populates the table right away and puts that stages there as well. So just a very powerful tool to just put in all information in one location so far. Now from there as well too, I can actually create a real degradant stage just by clicking on a cell and just say, okay, well, I want to create a force degradant stage. In this point, you can create several, and here I'll just make one. And once I've done one, it creates it down below. So now you can have not only your predictive stages of degradants, but also your real life one. And to do this, I can go into Processor, and now within Processor, this is a data set that's been pre-processed. Again, if you've been aware of our sessions, our power lessons, these are things that we discussed of how to take LCUV, LCMS, and fully process everything within our software, or just import from, let's say a CDS system. So here we do have an Empower dataset. Within this Empower dataset, you can import in the process results, the validated results here. At that point, you can either import directly into Luminata, or in this case, what we've done is we just associated molecules. And when we associated molecules here, we can assign it per peak. So once this is completed and you've done everything here, you can then just upload it within Luminata and just choose the stage of interest. And once you have it, the stage of interest, you can append it to it, and from there, it will show up in Luminata as well too. So here, I just append that record and the data set within Luminata, and it will add it within that record set that not only has your theoretical degradants, but also your observed degradants. And now you see that down below, and it's all connected to the API of interest. Now, the thing that's very nice about the software too is not only do you have your theoretical degradants, but you can also select here, and when you select it and you select any cell, you can add degradant information. So when you're adding that degradant information here, you can actually view how it was originated, what experiments you ran, was it acid-base heat, peroxide, and note that this is all customizable. So if you had something specific, such as a specific peroxide that you did, you can add that here as well. So you can place in more information in this case for how the degradant was completed. So I'm going to just zoom back out, and I'll go to the last part of this portion of the live webinar. So here we will go into a record. So this portion, we're just going to talk about how the software allows you to do batch processing. So in this case, it's a verapamil example. And the reason why I'm using this example, it's just a very easy test case where a user can see that you're taking in LCMS data with a predefined SD file, and then you can just do your batch processing. So you'll note here that I've changed my screen and I clicked on forced degradation. And once I click on forced degradation, I'll start over here. So let's just say delete all, and we'll start new. So this is my screen for the dialog box for how to look at stress testing and getting started with matching my degradants and possibly elucidating my compounds. So here I just click new. It takes the project name already here, and it places it as my sample name. Under conditions, the same ones that you saw before in the earlier example, it uses what it's seen in my configuration. If I'm very specific, such as for peroxide, like I mentioned, you can add that here as well. So here I can just say acid and then put that here, and you'll note that that gets denoted within the project name. From there, I can go to the folder and just select the file formats that I have. So here it's already been loaded within this folder, and it places it down below. So it recognizes all these folders. And again, in these cases, when I'm looking at LCMS data sets, here, since I haven't found all my degradants, they haven't been processed at all. So here, I can just load everything, see what they are, and then just view it. From there, I can choose differing time points. So in this case, let's say if I use minutes, I place it under minutes. And the most crucial thing at this point is because I'm taking a degradant list, it populates down below. So this is the SD file that it's populated. From here, the software is going to match which API if I selected in the background. So you'll see that I've selected verapamil here. It recognizes that this will be the degradant or the API that will be degraded, and it will create all my stages through that one aspect. Once you're happy with this portion of it, you would just click Next. And if you're familiar with our other pieces of software, such as MetaSense, it's very same taste and same flavor. You can then, main things to select here is the algorithm of how you want this done, such as IntelliTarget that we have internally, and the mass accuracy. So I would just click Run, and it'll just go through it. Now, for webinar purposes, I'm just going to click Cancel and just finish that portion like we ran it. So here, I would run it. But for the demonstration, I'm just going to show a finalized record so you guys can see it better. So let's go to a finalized record. And within this finalized record, I can just go into my different view, like I mentioned earlier, my forced degradation view. And you'll note what occurs when I just clicked on my new view. I see my trend plot. I see all my degradants at every time point with specific names. And you'll note as well that wherever I click on any of the stages, it will show that data set as well too. So you'll note that that blue triangle is moving as well. And like I mentioned just a little bit earlier, the top line or the top row in each case is going to be a verapamil. So you'll note that if I just hover down the line, that you're just seeing that it's the same API of interest with all possible degradants at every level, at every stage. So just getting that rough idea of what's occurring and what's being seen right now, and being able to view that and just having a targeted list. Like I mentioned right now, if you're looking at this portion, there isn't an easy way to go through and just distinguish through the targeted list all the data sets, especially if there's a lot of data like everyone mentioned in the poll. How do you handle this? What occurs? So just having this one capability here. And again, why is this important? Last year, we did a white paper with Dr. Steve Barchi, who's the president of his own consulting firm. And within the firm, it specializes in solutions in the most difficult stability, impurity, analytical, solid state, and formulation issues. Steve worked with Lilly up until 2005, and he has about 30 years of experience in the pharmaceutical industry of what's occurring with stress testing. And what Steve and I did when we started looking at the focus on the white paper, we wanted to look at gaps that he's seen and I've seen as well. And the biggest things that we noted that, for predictive software, everything was, there was already software out there that looked at it. But the gap that he saw was how were people handling their degradant list? How are people actually processing all that data to match all of their target lists, and then from there elucidating possible degradant compounds that they weren't aware of. And right now in the market, when we were discussing it, there was no simple way of just going through and looking at it. And through that, Steve and I wrote this. And just again, if after this session, if this is of interest, please we'll make that one of the poll questions at the end if you would like us to reach out to you and discuss this portion further. So really, the main thing to get out of just all of these operations and going through with Luminata is building a trend plot and building a numerical table where you can look at these trends before something bad happens. Again, for everyone that's on this webinar, you're familiar that if you're working on a project constantly for 2 to 3 years and you're familiar with it, it becomes very easy to look through and go through. But the difficulty here is what happens when you have a project that's 5, 10, or 15 years old in drug development? Where do you go? Do you go back to Excel? How do you look at the control limits in SharePoint? What happens? And that's really where the disconnect happens. And for us, it's really taking the bench information that you have and you've done and bringing that into a boardroom to make those types of decisions soundly. Where something that's not familiar that was done 10 years ago, you can just load it up, see what's occurring, and go, okay, this is what happened at this specific batch of this degradant. Now we can prevent this from occurring again. Now, to summarize, I'll go back to that one slide that we had earlier. If we look back in that slide again, same project, different team leads for specific steps of that project. And in this case, we'll focus on the stakeholders such as target degradant and just looking at new degradants. How is this handled? Where is this being placed? And we believe that we have a solution that allows every user to take all the information they have from a CDS system, in-house systems, ELN, and LIMS, and place it within Luminata where you can make those types of decisions, go through that, and then really break down what's occurring and what happened down the line for your use case and for those cases within drug development.